Hello, welcome back to Sri Sai Tech Edu YouTube channel, Read Lead Success. We're already started with the network analysis and control systems, module 1, and in that first chapter, basic circuit and elements. Today we are going to study the new topic in this chapter. We have already done with introduction, circuit components, definition, sources of electrical energy and source transformation. Today we are going to learn general network transformation. Now we are going to start with general network transformation. Here in general network transformation, there are two networks, that is star network and delta network. Star network is also known as T equivalent, that is the T network, and delta is also known as pi. Star is also called as T network or Y network. Okay, delta is also called as pi network or pi section, or it is represented by a triangle, that is delta network. Why like that? If you see this, if you rearrange them, it looks like star. If this is one resistor and this is one resistor and this is one resistor, if it is in this form, how it is looking like star and also it is looking like Y. So it is known as T or Y network. While delta, here it is looking like pi. C, it is looking like pi, no? So it is called as pi network, or it is known as delta network. Why? Because when if you make the arrangement in this way, this is also delta network. Like this base is same and this becomes like this. So it is also called as delta network. So we need to remember all the ways of representing, so that in a question they may ask star network to delta network or T network, Y network, or in the if they give delta like this, then also you should know that which network to which network you want to convert. Now we'll write the equations from these networks. For T section we will take Z1 OC. Z1 OC means keeping Z1, we are open circuiting this second port. So what happens, there will be no current flow here. So there is no current flow and this is 0 this side. So what happens, Z1 OC is Z1 plus Z3 only. Why? Because this forms a series resistance. So Z1 plus Z3, as there is no current flowing through this. In the same way, Z2OC. Z2OC how you will get, by keeping Z1 open circuit. Z1 open circuit. If Z1 is open circuit, what happens? There will be no flow current of in this direction. So Z2 plus Z3. So this will form a series connection. So you will get Z2 plus Z3. Then Z1SC. Z1SC means Z1 short circuit. How we are short circuiting? We are keeping Z1 like this and we are short circuiting Z2, that is not Z2, like second port side. So how we are going to represent that? These two are in parallel, no? Parallel equation, how we will write? 1 by Z2 plus 1 by Z3. If you take LCM, then what you will get? Z2 plus Z3, Z2 plus Z3 by Z2 Z3. As I told initially only, we will get 1 by Z equivalent here. 1 by Z equivalent here. To get Z equivalent, we need to reverse. So when you reverse, you will get Z2 Z3 by Z2 plus Z3. Okay. Z3 by Z2 plus Z3. So that these two resistors or impedances are in series with Z1. So we are adding Z1. So Z1 plus, so Z1 is in series plus Z2 Z3 are in parallel. Z2 Z3 are in parallel. Parallel we can represent in like this, two lines. In future in sums also I have represented in this way only. Z2 parallel Z3 means they are in Z parallel. So if there are two impedances, easy way here is, if there are two impedances in parallel, we can directly write product of those two, like Z2 Z3, by addition of those two. This is the Z1 ZC. Now in the same way we write for delta. How to write for delta? Z1 OC. What we will do, we'll open circuit this. If you open circuit this, what happens? There will be no flow of current here. This will be closed. But if there is no flow of current here also, this connection, how it looks? This connection will be like, there will be no no current, but here what happens? ZA is in parallel with ZP plus ZC. Why? Because here ZB and Z3 become series. Okay, I hope you are getting. Here Z2 will be making open circuit. As Z2 is in open circuit, how the circuit looks like is impedance ZB, and this way, in this way it looks in this way, and this first port will be like this only, 1 dash. This is ZA, ZB and ZC. So these two are in series, no? So ZP plus ZC, ZP plus ZC is in parallel with ZA. Okay, as it is in parallel with ZA, ZP plus ZC into ZA. What I told, if two things are in parallel, then what we can do? ZB plus ZC into ZA by ZB plus ZC plus ZA. These two plus ZA, and product of ZB plus ZC into ZA. This way we write. The same way we'll take Z2 OC. We'll open circuit this. Then what happens? This will be not there. This will be not there. So what happens? ZA and ZB will be in series. So what? So ZA plus ZB into ZC by ZA plus ZB plus ZC. Okay. In this way we write. Then Z1 SC. When Z1 SC means short circuiting this. When short circuited, here one more important thing I am going to tell is, when a resistance or a impedance is in parallel with a short circuit, we can remove that resistance. So what happens? ZA and ZB are in parallel. Okay, ZA and ZB will be parallel, and why? Because here it will be the resistance will be removed and a line comes here. So this, if you see, it looks like a parallel. So ZA ZB by ZA plus ZB. In this way we write. Okay, Z1 ZC. Remember this, if resistance is connected in parallel with a there is nothing, like it is a short circuit, then that resistance can be removed. So these two will be in parallel. So product of ZA ZB by ZA plus ZB you will get. Then Z1 OC signifies impedance measured at port 1 with port 2 open circuited, as I said, and Z1 SC signifies impedance measured port 1 with port 2 short circuited. Port 1 with port 2 short circuited. Similarly, Z2 OC and Z2 SC. Okay. In the same way, Z2 SC also can be written, and Z1 SC can be written, and Z2 SC also can be written for the T section and the pi section. What we should do then? We will short circuit here. If you want Z2 SC, for example, Z2 SC, then what we will do? We will short circuit this. Okay. If you short circuit, what happens? Z2 plus these two will be in parallel. These two will be in the parallel. Z1 Z3 by Z1 plus Z3. This will be in series with Z2, like that. Here nothing. Here what you will get is Z2 you will get here plus Z1 Z3 by Z1 plus Z3. If first port is shorted, here second port is shorted, so only we have written as Z1 SC, and here it means Z2 is shorted. Okay. In the same way we can write Z2 SC for the pi section also. So the main thing why we are learning this general network transformation is that we can convert star to delta and delta to star. Nothing but T to pi section, T to pi section to T. We can convert using some formulas. We'll derive that formulas in further slides. See, delta to star conversion proof means from delta network we're converting into star network. Okay, how we are doing that? We already got these equations, no, initially that this is what equations what we got for T section and pi section. We are going to equate them like Z1 OC equals to Z1 OC of this is T section ka and this is pi section. We are going to equate them, the equations what we got. For Z1 OC of T section what we got Z1 plus Z3, and here what we got ZA into ZB plus ZC, ZA plus ZB plus ZC. The equations what I have mentioned in previous slide, the table is here. Now we are going to equate them accordingly. After equating, we subtract this equation 3 from 1. If you subtract what we get, this Z1 and Z1 will get cancelled. As it is subtracting, Z1 get cancelled. Z3 minus Z2 Z3 by Z2 plus Z3, and this ZA ZB plus ZC minus ZA ZB by ZA plus ZB. You get this equation. After rearranging and taking LCM and all, these all for the understanding I have done and I have shown for you. If you see this, you will understand how the LCM is taken, how it is done. After doing that, what we get, the last equation as Z3 is equal to ZA ZC by ZA plus ZB plus ZC. Okay, I'll in further slides I'll easily tell how to get this, how to memorize this formula. Easily get formula, how to convert. Okay. For now, you just know, you should know the proof, because they may ask in exam proof of delta to star to delta, so that you know, should know the proof. For that you need to calculate in this way. Okay. In the same way, we got what Z3 means in terms of Z3 you got means delta to star means what? We are converting delta to star network equations, means Z3 is delta star network, no. So Z3 is represented by ZA ZC by ZA plus ZB plus ZC. Okay, to get Z3 value, to convert to star, to write in the form of star, Z3 will be equals to the already given equations of delta. If you put, no, you get the star value Z3. In the same way, if you equate based on this Z3 in equation 1 what we have in the previous slide, what you get? Z1 equation. Z1 what you get? To get the value of Z1, ZA ZB by ZA plus ZB plus ZC you should do. Okay. Then in equation, put Z3 in equation 2. Then what you get? Z3 value, whatever you get if you put in the previous equations, and you will get the next other values, no, easily. So in this way, Z2 also you will get. Z2 what you will get? ZB ZC by ZA plus ZB plus ZC. Okay. These are the equations. All these three equations you should remember. For the proof that you got correct or no. The easy way how to memorize the things, I will give in the next slide. In the other slides, I will show. After converting from star to delta, there is a table you can easily memorize. I will show that. This is what delta to star conversion. Now we will see star to delta conversion. Star to delta conversion. In the same way, we will consider those three equations, compared equations. We'll consider equation 3. From equation 3, what you will do? If you see here, if left hand side, if you take LCM, then you get Z1 Z2 plus Z1 Z3 plus Z2 Z3 by Z2 plus Z3. Here ZA ZB by ZA plus ZB. Substituting Z2 plus Z3. In equation 2, you know, from Z2 plus Z3 is what? ZC into ZA plus ZB by ZA plus ZB plus ZC. You should remember those equations. If you compare with the previous, one suggestion is, when you are doing this conversions, please write down and do, so that you will understand. Why? Because I can't put everything in one slide, no. So I have put it the equations in the previous slide. So Please see those equations, so you'll get to know how this Z2 plus Z3 form equation is this. This I've took it from the equation 2, initially what as mentioned. Okay, if you do that, some cancellation happen, then you get in this way. From this equation, you can directly get ZA, ZB, ZC. Like to convert star to delta, you can directly get. How we are getting? ZA is equals to Z1, Z2 plus Z2, Z3 plus Z3, Z1 by Z2. Why Z2? Because Z2 equation already we got it as ZB, ZC by ZA plus ZB plus ZC. No. So we can put that in this equation. See, this equation, this form is there, no? This total is Z2. If you substitute Z2 here, you will get ZA in terms of the star form. Like star equation values you'll get Z1, Z2, Z2. If you have only Z1, Z2, Z3, no, you don't know ZA, ZB, ZC. To calculate ZA, ZB, ZC, you should know Z1, Z2, Z3. So you need to convert into those forms. So this will become Z2. Then ZB, what will happen? If you carefully see this equation itself, then ZA, if you remove this, ZA, ZC, ZA plus ZB plus ZC. What it is? Z3, no? Z3. So if you substitute Z3, the ZB will become, this is what Z3. If you substitute that, this will come denominator. So you will get Z3 here. In the same way, if you keep aside this ZC, what you will get is ZA, ZB by ZA plus ZB plus ZC. That is what Z1. If you substitute Z1 in this place, then you will get in denominator. So this is the equation for ZC. So you will get all the values to convert that needed for the delta conversion. That it is already converted into delta. These are the equations you need to remember. Now I'll tell the easy form to remember these values. No need to remember Z1 means this only you should keep, Z2 means this only. No, nothing like that. I'll tell you the easy technique in the next slide. Yeah, this is the slide which is required for you people. You need to know this formula or this thing, so you can write any of the delta to star or star to delta. First you see, initially I combined both, means star and this is delta and this is star. No, if you see how to convert, how we are converting it. See, initially we'll see delta to star. This is delta. This delta you know already. You don't know Z1, Z2, Z3. Okay, you want to convert this delta form to this star form. Okay, to convert this delta form to this star form, to get that, what we need to remember is, for getting Z1, product of adjacent resistance or impedances. To get the Z1, product of ZA, ZB, adjacent means now on side of Z1, sides of Z1. If you want Z1, you should look for side of Z1, what values are there, ZA, ZB. So ZA, ZB by ZA plus ZB plus ZC, like sum of all the resistances, sum of what, ZA, ZB, ZC. You know ZA, ZB plus ZC. Then for Z2, what we'll do? For Z2 again, what are the adjacent resistances? ZB and ZC. Take product of ZB and ZC by ZA plus ZB plus ZC. The ZA plus ZB plus ZC is common in all the equations. Then for product of, then again Z3. For Z3, what we need to do? We need to take ZA and ZT. Why? Because it is adjacent to Z3. ZA, Z3, ZC product by ZA plus ZB plus ZC. You can easily remember in this way. You no need to keep that whole proof in mind. That proof only for the exam sake you need to practice if they ask for the proof to be done in the exam. But for solving sums, you can easily remember these equations. Then star to delta. Star to delta, how we are going to keep in mind, easy way is, first thing is sum of adjacent resistances or impedances products, means Z1, Z2 plus Z2, Z3 plus Z3, Z1. How it is in all the cases, this numerator is same. See, if you want, numerator is same. What it is a product of the adjacent impedances and adding them. Z1, Z2 plus Z2, Z3 plus Z3, Z1. Then opposite resistance of impedance. See, if you want, it is like star to delta, no? You know star connection. You know this star connection. You don't know the delta connection. If you want to know that, if you want, for example, the delta value, that is ZA. If you want ZA, the opposite of ZA, what it is there? Z2. So, the opposite resistance you need to divide. So, you will get ZA. Then if you want ZB, the opposite resistance is what? Z3 in the star. So Z3. If you want ZC, the opposite resistance of ZC is what? Z1. Okay, Z1. So Z1 you need to divide. So you will get ZC. This is the easy way you can remember. Opposite you need to check. Any network, one more important thing is any network, you better try to simplify in this triangle and star form so that it will be easy for you to know the opposite resistance or the adjacent resistance, and it will not be confusion. And I'll solve some questions, so it will be very easy for you to do, and it is very easy to convert delta to star or star to delta. See the question, with a simple question I am starting. First, initially what we are converting here is delta connected network to Y network. See, here delta can be also known as pi and also can be written as delta in this way. Delta, they can give in delta like this also. And we are converting it to what? Y connected. Y connected or T connected or star connected. Y connected, T connected or star connected network. We are converting from delta to star. How to convert? It's very easy. First, we'll write the way we want. See, this you take as base, okay? This is 17. Then you connect. If you connect here also, if you connect in this way is also same. If you connect the resistance in this way is also same. Okay. The points are not changing, no? The same points are there. On the same line, no? On the same line the connections are there. So you can connect anywhere. Understand? If you connect here also, it will do the same work. The same thing will be there on this. So resistance can be connected here. Resistance can be connected in this way. Okay. First you convert in that way. We have written, no, already. See 33, 21 and 17. What we require? This R1, R2, R3. It is not like the previous how I have shown in the proof. In that way only you need to write. You can write this as R1, this as R2, this as R3. Or you can write this as R1, this as R2, this as R3, or this one R1, R2, R3. But you should know the easy technique what I have given, the table, no? The table is very important. You need to remember how to remember that. The table, from that easily you can know. First, if you want to calculate R1, what we need to do? R1's adjacent resistance are this 21 and 33. So you will take product 33 into 21. After taking product, what we need to do? We need to add the resistances 33 plus 21 plus 17. Sum of all the resistances. You will get R1 value. R1 value you got. Then R2 opposite resistance is 17 and 33. 17 and 33 product by 33 plus 21 plus 17. Sum is same. Then you will get the R2 value. In the same way R3. R3's opposites are 17 and 21. 17 into 21 product by 33 plus 21 plus 17. You get it as 5.03. You can now write this network in this way. If you see R1, this is R1 equals to R1. R1 value what you got? 9.761. You will mention here. Then R2 value what you got? 7.901. You will mention here. Then R3 value what you got? 5.03. You will mention. Simple. Star, here we are converting delta to star. Now we will see in the next slide how to convert star to delta. One of the equation we will see now. Here you see it is given in this form: Y connection or pi connection or T connection. I'm sorry, it is not pi connection. It is Y connection or T connection or star connection. This connection is given. What we want? Delta connection network or delta or we can tell pi connected network. How to convert. We will see using that simplest way what I told. We can easily solve. See, you have already 1.3K, 2.1K and 4.7K. We want RA, RB, RC. Okay. To get RA, what we need to do? As I said, to convert star to delta, what we need to do is, first we need to take product of each adjacent resistance and add them. 1.3K into 2.1K plus 4.7K plus 1.3K, 4.7K plus 2.1K plus 2.1K plus 1.3K. In all the equations, if you see, this is common. Numerator is common. You'll write. Then to get RA, what we need to do? The opposite resistance what you have, 2.1K, you will divide it. Then to get RB, opposite resistance what you have, 1.3K, you will divide it. If you want RC in the form of delta, you want, no. So if you want RC, 4.7K is the opposite resistance. So you will divide it with 4.7K. You will get easily 8.91, 4.40 and 3.98 ohms. Now we will see next question. Use the technique delta Y conversion to find Thevenin equivalent resistance of the circuit. Here they have not mentioned to convert from delta to star or delta. They are telling use this transformation delta Y or Y delta conversion to solve this circuit. To do that, what we should do? First you write the equation in this way, the same problem in this way. Here if you see, this is looking in delta form, right? You can convert this, or else down one is also delta. It is your wish, but here I am converting upper portion delta into star. If you want, you can try with the down portion into delta and try, you will get the same answer. First I will take the upper portion. Upper portion if you take as a delta, I have even mentioned inside R1, R2, R3. You can take any way. I am telling you once again, here R1, R2, R3 you can mention in any way, but the calculation should be correct. Okay. Here for calculating R1, what we need to do? R1 is what? We will, this is R1. If you want the delta form, what we need to do? Sorry, if you want the star form, this is already in delta. If you want star form, R1 if you want, what we need to do? Product of this opposite. 1 into 4. 1 into 4 by 4 plus 3 plus 1. 4 plus 3. Sum of all the resistances what you have in the delta. What you get? 4 by 8 equals to 1 by 2. Then R2. In the same way, R2, the adjacent is 1 and 3. 1 and 3 product by same 8, 3 by 8. If you want R3, the adjacent is 3 ohms and 4 ohms. You take 3 ohms and 4 ohms product by 4 plus 3 plus 1. You get 3 by 2. After doing this, how this circuit looks, we will see. The circuit looks in this way. So now we are converted. This delta form we should not draw here. Should not draw this here. Why? Because we have already converted the delta to star. So this R1, this is R1, you have got 1 by 2, R2, you got 3 by 8, this is R3, 3 by 2. You got no, so you will write in this way, resistances, you got these resistances and 2 and 5 are there, like that only we will. Now if you see here, what you can see, this 3 by 8 and 2 are in series, this 3 by 2 and 5 are in series. These two are in series, these two are in series. So you can add up, no, if you add up, what you get, 3 by 8 plus 2, 3 by 2 plus 5 and 1 by 2 is same like that. After that what you get? After adding you will get 9 by 19 ohms here, 13 by 2 ohms here. If you see these two are connected in parallel. If these two are connected in parallel, what to do? We will taking product of these two. Like in parallel what we need, what we do, 9 by 18 into 13 by 2 by, only two resistance are there. No, you can directly do in this way, 19 by 8 plus 13 by 2. If you calculate this, what you get? If you calculate this in this way, as it is in parallel, you get, see 19 by 8 into, I have even mentioned here, 19 by 8 into 13 by 2 by 19 by 8 plus 13 by 2, you get 247 by 142. And again if you see these two are in series. As these two are in series, you will add up. After adding, you will get 159 by 71 ohms. You got the Thevenin equivalent resistance. To find the Thevenin equivalent, you will get in the future concepts. But here directly ask Thevenin equivalent resistance. But For conversion, Thevenin equivalent resistance is nothing but this only, RTH. So delta into Y conversion, you should get the final resistance value. Here after converting, it is a resistor network. No, you need to get a final resistance value. This is what we do. Therefore, Thevenin equivalent resistance equals to 159 by 71 ohms. Understood? We'll go to the next question. Now we'll see the next question. Here the value of R need to be found with equivalent resistance 70.6. What here is that in previous question what we have seen that equivalent resistance we have found. But here they have given the equivalent resistance. They want us to find the R value, We can do that. The same way, the same procedure what I have done in the previous question we will do. Later on the equation will be in the terms of R, that will equate it to 70.6. So you can easily get the R value. See, now here I have to the down portion as into star to just clarify that any of the delta can be converted into star. This is looks like delta, no? Now we'll convert into star. To converting into star, what is the technique? R1 is equals to product of the adjacent, 42 into 68 by 42 plus 68 plus 200. You get 9.213. Then R2, how you will calculate? R2 is nothing but product of 42 into 200 by 42 plus 68 plus 200, 27.096. Then R3, how you will get? R3 means the opposite, the adjacent resistance are 268, 200 into 68 by 42 plus 68 plus 200. You will get 43.871. And we'll get R1, R2, R3. After getting R1, R2, R3, the network also changes. No, how it will change? This 100 and R is same. These resistances will convert into star, from delta to star. After converting, if you see, these two are in series, these two are in series. Then add up. If you add up, you will get the equations in this form. After adding up, if you see, these two are in parallel. If these two are in parallel, you need to calculate the parallel resistance. To calculate the parallel resistance, how we are going to calculate? We will see. 127 and this is in parallel plus 9.213. These two are in parallel, and after parallel these two are in series with 9.213. No, so plus 9.213. If you calculate parallel, 127.096, product of these two by addition of these two, this will get the parallel equation. After doing that, you will get in terms of R. After getting in terms of R, if you rearrange the things, I told it will come in forms of R. Then you will get R equals to 74.865 ohms. Okay, this is the R value. Same, easy way. You will get the same, the method is same. But it will be like, they'll ask you the R value. What you will do, you will get some equations in terms of R. You will equate that into 7.6, the given equivalent resistance. If you equate with that, you will get the R value. That's it. We'll go to the next question. Find the equivalent resistance between B and C for the circuit using star delta transformation. This is the previous year question paper's question. So I wanted to solve. I am solving it now. It is also easy. We will see. If you see, this looks like delta. See, you can take here. Again, I am telling you once again. This also looks like delta. Okay. You can convert this also. Here, this also into a star. But I have took this. Before converting, to make it easy, what I have done is, as I told, this point should be connected here and this end point should be connected here. So we can connect in this way also. This points also we can connect. Same, it is connected in this way also. It is connected to this then this point. If you put in this way also, the wire is reduced. That's it. Okay. Don't get confused that here it is like this, but here it is took like this. It is same. After doing this, you will write the star form inside. Delta to star you are going to convert. To convert delta to star, what we do? For getting R1, opposite resistances, opposite like the opposite adjacent resistances of R1. What it is? 20 into 30 by 20 plus 50 plus 30. Then you will get 600 by 100, 6 ohms. Then R2, you will get 30 into 50. 30 into 50 product by 20 plus 50 plus 30, you will get 15 ohm. For R3, what it is, the product adjacent resistance 20 and 50. If you calculate that, you will get 10 ohms. After calculating how the network looks, it looks in this way. This 13 is same, 24 is same, 10 is same. This looks like star. If you see 6, 10, 15, if you see here, these two are in series and these two are in series. Okay, if these two are in series, you can add up. After adding out, you will get 24 plus 60, 30, and 10 plus 10, 20. Again, if you see 30 and 20 are in parallel. 30, 20 parallel means what you will do? 30 into 20 by 30 plus 20. 30 plus 20. If you do this, you will get the parallel equation value. If you do that, what you will get? 30 into 20 by 30 plus 20, you will get 12 ohms. After getting 12 ohms, if you see, these all are in series. You can add up 13 plus 12 plus 50. You will get 40 ohms. So the equivalent resistance of this equation between B and C is 40. That's it. It is very easy. You need to just identify what is which is in form of star or delta. So you need to convert the respective star to delta or delta to star and make it reduce the circuit in the form of parallel or series resistances, and you can easily add up, or if it is a parallel, follow the parallel rule of the resistance, you will get easily the equivalent resistance. We will go to the next question. Use the technique of Y delta conversion to find the Thevenin equivalent resistance. Here R, here if you see all the resistances, here each R is 10, means this is 10, this is 10, all resistances present here are 10. We'll calculate this now. If you see, this is looking in the form of delta. If you see, right now it is looking how this is base. This point can be connected here also, no? So it is in this way. So it is looking like 10. If this is in the form of this, no. See, this point can be connected here also. This point can be connected here also. So it is in the form of delta. If you understand, I hope you are understanding. So this is 10 and this is 10. So we can make into star. Okay. To make into star, R1, R2, R3. Delta to star, you will get R1 is equals to, R1's opposite is what? As you can see, all R's are 10 only. So the equation is same for all R1, R2, R3. Why? Because for R1 also 10 into 10 by 10 plus 10 plus 10. For R2 also product is 10 into 10. R2 opposite is 10 in the adjacent resistance are 10 into 10 by 30. So again you will get all R1, R2, R3 as equal resistances. So you will get 10 by 3 ohms for all R1, R2, R3. After conversion, what you will get? 10, 10, 10, and this is 10. This is 10 by 3, this is 10 by 3, and this is 10 by 3. If you see, these two are in series, these two are in series. Add up. If you add up, what you will get? 10 plus 10 by 3 is 40 by 3, and this is 40 by 3. And between these two also are in series, this is also 40 by 3. Again, if you see, this looks like what? Delta. Delta. As it is looking like delta, again we can convert into star. To convert to star, what we need to do? We need to do the calculation. For RA, what is the adjacent resistors? 40 by 3 and 40 by 3. So 40 by 3, 40 by 3 by 10. This is 10 plus 40 by 3 plus 40 by 3. You will get 4.848. For RB, what it is? RB's adjacent resistance are 10 and 40 by 3. 10 and 40 by 3 by 10 plus 40 by 3 plus 40 by 3, 3.636. For RC, same, in the same way. The adjacent resistance are 10 ohms and 40 by 3 ohms. You will take product of those two, and by the same denominator, adding of all the resistances, you will get 3.636 ohms. After that, how it looks now? The network looks like in this way. Here RB is 3.636, this RC is 3.636. Just compare these two. This is RB, this is RC, and this is RA, 4.848. And this 10 and this 40 by 3 is same. If you see, these two are in series, you can add up, and these two are in series, you can add up. After adding up, what you will get? This 3.636 is there, and this is in series, so we added up, we got 13.636. As these two are also in series, it is added up in the next step. If these two are added up, you'll get 18.181, that is 40 by 3 and 4.848. If you see these two are in parallel, you know, taking product of these two by adding these two, you will get the value. Again, if you see these two are in series, add up, then you will get 11.428, nothing but 11.43 as equivalent resistance. The equivalent resistance is 11.43. See, now the sums are completed. I have done some 5 to 6 questions. I have done all the different types of questions which are very useful for your exam. These are only questions will come for exam. I can't assure you. Why? Because I am just telling you the concept. You need to practice different questions so that you will be very perfect. So what I have done is some practice questions I have given for this topic also. So if you see this type of question I have already solved. It is in what? Delta form, convert it into star. It is in what? In star form, convert it into delta. And the values also I have given. Please check it. That it is correct or no. And this just now I have solved in previous slide. Previous slide. Here we have to cast 10 as R, but here 2.2k. You'll get answer as this. You just solve. You will get to know. And here also this type of sum also we have solved, right? Here R we have took it here R. Okay. Then what will be the answer? You need to find R. We need to find the equivalent resistance is 9. These are the sums. If you get still more sums, please do solve. And if I get some more, still more sums which are very important, I will separately put it as like star delta conversion problems, and some other video also I will do in future if required. But till now this is the concept wise I have done some problems. If you still want any problems, if you still want more clarity, you just please comment in the comment box so that I will surely try to do some more problems and make you understand. Please solve these practice questions. If you have any doubt, you please comment. So I will stop the video here. So we are done with introduction, circuit components, definition, sources of electrical energy, source transformation, and general network transformation is also done. So we are left with other topic to complete first chapter of module 1. So mesh and node analysis. I am thinking of doing mesh and node analysis a separate video, like mesh analysis separate and node analysis separate, so you will easily understand and I can easily solve some different problems of mesh analysis and node analysis in the further video. So for this video I am stopping. Please do solve the questions. Thank you. From Sri Sai Tech Edu, read, lead, success. Don't stop reading.